Thanks for watching the Nebraska Engineering Ambassadors Teaching and Outreach channel. Let's start with a little video. Oh, there you go. Oh. All right, so normally I would ask you guys, what do you think that is? But both since I accidentally went to the next slide and also because you probably found this video on YouTube, you probably know that it is a video about robotic surgery. So engineers have designed robots that can help perform surgery in order to save people's lives. My name is Abigail Howarth. I am a biological systems engineer with an emphasis in biomedical engineering at UNL. So robots built by engineers make lives better in every day in a lot of different ways. First, we're going to talk about robots and how they work. Then we'll move on to surgical robots. And then we will talk about the role that engineers play in designing these robots. First, let's start by talking about robots and how they work. So engineers usually design robots for tasks that are too difficult or tedious for humans to perform. Can you guys think of any? Just kind of, if you think about it for a minute, you should be able to come up with some examples. But one would maybe be like an assembly line at a factory or something like that. Another one could be in outer space. Obviously, that's conditions that are too dangerous for a human. And this is actually sort of the other part of a surgical robot. This is the console that helps the surgeons control the robot. Robots are powered by electricity, and they are programmed using instructions in the language of computers. So I don't know if any of you guys are familiar with any computer programming languages, but maybe you have encountered something like C or Java, or at least heard of it. But that is sort of the language of computers that engineers use to code and to talk to computers and instruct them in what to do. And you have to be very sort of specific and straightforward when you're giving instructions to computers because they're not quite as smart as people. But they are very good at doing computations very quickly. Also, batteries usually power robots or some form of power, but often batteries, just so that they can be sort of independently functioning, because batteries store chemical energy, and that is one way to power a robot. There are other ways as well, like maybe solar energy or something, but that's not the main focus of this presentation. Robots are powered by electricity, and they are programmed using instructions in the language of computers, as I said before. The coding sort of is like a treasure map telling the computer what to do, the robot where to go. You, like I said, need to give computers very explicit instructions. Now that we have kind of covered the basics there, let's talk about surgical robotics. So I'm sure that all of you probably know someone who has had to perform surgery for some reason or another, because there's a lot of reasons why someone might need to perform surgery. Not everything that can be fixed by medicine is outside of the body, some of it's inside, like maybe unclogging a blood vessel or doing something like repairing a part of the spine that's buried deep in the back, or removing a tumor that's also sort of buried deep in the body. But a lot of the times, surgeons need to get into the body to see what's going on and to fix it. So that's what surgery is for. In 2000, the government approved this Da Vinci surgical system, which has been used like in the US and internationally a pretty large amount lately in the last few years, and is kind of grown in popularity. And so it's something that's on the market right now and that people are already using, which is cool. You don't always see that with new technology. A lot of it's still in development. So a sort of high definition, magnified, three-dimensional view of the surgical site is possible with the robotic system, right? So the robot's arms, they have these little cameras, which we'll go into a little more later. But the surgeons who use this system, they can sort of see the site better, right, through these cameras than they would be able to if they were just looking with the naked eye, because they can get all the way up close, and the cameras are actually like on these little arms they can stick into places. And these little tools help them complete the surgery as well at the end. So put your finger in front of your eyes like this and sort of move it back and forth. What do you notice? You sort of see two images of your finger, right? And if you move it close to your face, those two images get further apart. And if you move it farther, those two images get closer together, right? So that's how we actually perceive depth. Now, if you're focused, then you can perceive that it's farther away like this, closer like this. But if you're relaxed and you can really see that what your eyes are doing, it's sort of comparing the image that you're getting from two different angles and combining them together to calculate the depth, actually, is what your brain is doing. So just like the way that our human eyes do that, the camera for the Da Vinci surgical system actually has those three little dots that you see here. All of those are sort of like the equivalent of one human eye. So it almost has like what you could say three eyes. It's actually just three lenses, but you get the idea. It gives you depth perception because you're able to see it from different perspectives and compare those. It's almost like kind of the level of virtual reality of Ready Player One. If you've seen that, it's, you know, if you're in 3D or closer to reality, that's kind of the idea. It's a little cheesy, but. So these mechanical arms allow the surgeon to perform the tasks that they would be without the robot, but using the robot, right? So I don't know if some of you guys probably play video games and you use a console to control the movements of your fictional character, right? But in a robotic surgery, the surgeons, they use a console and they use the movement of these little arms that they have. They move them around, and that moves the arms of the robot, which perform the surgery by cutting things, clipping things, pushing things. And it allows the surgeon to both keep their hands clean, and he also has sort of a more clear view from the console, and that helps him perform the surgery better. Now, another benefit of robotic surgery is that it is a form of laparoscopic surgery, right? So normally, if surgeons want to see inside the body, they have to kind of make a big line down the center so that they're able to sort of open it up and look inside, which is, you know, it's a little gross, but that's what they do. But when you have these little tiny cameras that you can stick in, and the surgeon is able to see the surgical site through those cameras, then they don't need to be able to see it with their naked eyes from outside. And in that case, you know, it allows the person to have much fewer sort of marks on them, much smaller cuts, and that leads to less pain, less blood loss, less scarring, and a quicker recovery for the patient. All right, so finally, let's talk a little bit about the roles that engineers play. Engineers design things, and then they're always working to make them better, right? So this is an instance of a surgical robot that some engineers are working to design that actually could potentially perform surgery on its own. Now, I think this one is kind of a ways from going on the market. We're going to talk about some other sort of improvements on surgical robotic systems that are more close to being in the works. But engineers are always thinking of new ideas and new ways to make existing inventions better, as well as come up with completely new concepts. But a lot of the times they're going to imitate stuff from nature. There's actually a company right here in Nebraska and Lincoln. It's called Virtual Incision, and it is developing a robotic surgery platform called Mira. That is the miniaturized in vivo robotic assistant. So this device is investigational. That means it is not yet commercially available. You can't go buy it right now, but it has entered clinical trials. So some people have agreed to have surgery using the system so that they can test it out. And hopefully, if all goes well, then it will enter the market soon, probably after small improvements, as is the case most of the time. So one cool thing about this system compared to the Da Vinci system is that it's simple. Right, so this allows the surgical to still be minimally invasive, but it is actually more affordable. So the Da Vinci platform, that costs about $2 million to buy, and not to mention that laparoscopic surgery in general costs about $2,000 to $5,000 for the patient, and the Da Vinci system costs about twice as much as that for a patient. But this system actually costs about the same as laparoscopic surgery. So it's still not like necessarily super cheap, but it's cheap compared to the Da Vinci system. So it's definitely a support. And even just that, I mean, just sort of having the price of this device, that will allow maybe more hospitals in more rural areas, even people in places that don't have as many resources, to be able to use this less invasive surgery system and probably be beneficial for them. It's also small. It's only about 2 pounds. It's only about the size of a human hand, like the actual robot itself. So there's also this companion cart, and that sort of has everything that you need to set up the device. It has wheels on it to move everything around. It has like support equipment, and it has an interface that you can use to sort of control all of the system connections and the camera and make sure it's functioning properly. And then obviously you've got the sort of surgical console, right? It's like a console, like your computer console, and that you can use to obviously see the video of the surgery. It has the hand controllers that the surgeons use, and it also has an interactive touch screen. So kind of much like your home computer, but obviously with much more fine-tuned controls and everything like that to facilitate the surgery. It's also a smart system, so it collects data. That data helps to monitor the procedure as it's going to prevent mistakes from happening. It also helps them to optimize the safety and effectiveness of the surgery by collecting all this data without necessarily taking up as much space. And it also just, yeah, so it's just kind of good in that sense. It's just a smart system. A lot of systems are learning to use artificial intelligence these days to make them better. Now, this is a game. I'm going to sort of explain one role or one part of the robot, and you guys can try to guess which type of engineer might work on it. So, which type of engineer do you think might work on sort of the electrical hardware and circuitry? That would probably be the electrical engineer, right? And there's actually really like intersection between these, so different people might work on different aspects. Lots of engineers are well-rounded, but just in general, engineers specialize in different areas so they can contribute in different ways. All right, who do you think might know about sort of the physiology of the human body and how it works and be able to take that into consideration? Probably a biomedical engineer, right? That's biomedical engineer's specialty. They're good at knowing about the human body and how technology that engineers designed is going to impact the human body. All right, what about the sort of mechanical arms and moving pieces of the robot? Who do you think would work on that? Probably the mechanical engineer, right? Mechanical engineers are all about moving parts, fluids, stuff like that. They know how everything's going to interact and how it's going to move spatially, and so they would be a great person to work on that. Finally, who's going to work on the programming of the robot and making sure that when the surgeon does what he wants to do, that the computer is properly instructed to do what it should be doing? That would be the computer engineer. All right, so now let's talk a little bit about the engineering design process. Some of you may have heard of the scientific process. Now, that's a process that scientists use. Engineers use a sort of similar process that is circular, but engineers always use this process, whether it's conscious or not. So it begins by asking a question, right? If we are an engineer, we always start with a problem that we want to solve. And we can ask ourselves, what is the problem? What do we want? What do we need? Right? Then we can imagine solutions. Now, at the stage of imagining solutions, there's not really limits. It's good to think outside the box. Engineers should be creative. They should think of new innovative ideas. And that's what happens during the imagine stage, right? But during the planning stage, some ideas might have to be eliminated, right? And other ideas have to be refined, sort of selected and refined in order to make them more practical and more realistic according to engineers' knowledge of science and math, right? To actually make something that's practical. And now that they have a practical plan, they can create the functional product or kind of a test product, right? But then you can actually work to improve that product. And when you want to improve something, you start by asking another question of how can we improve it? So the process just kind of repeats itself as you try to make new developments and meet new challenges as an engineer. So first we're going to talk about sort of how engineers can use scientific knowledge to imagine creative solutions to problems, right? Now, before any sort of concept can come to life, it first has to be an idea, right? And before that idea can come to life, it also probably has to be documented or communicated, right? So whoever thought of the idea of the surgical robot, they might have drawn a picture of something like this to communicate to other engineers what they had in mind. And engineers can use all sorts of tools like something like CAD. This is actually the CAD software. Engineers can use things like this to communicate their ideas in a lot of detail so that other people can help them construct whatever they want to construct. Engineers also collaborate and they prototype, and I'll talk a little bit about each of those, right? So I already touched on this a little bit before, but engineers, any type of design requires people that know about a lot of different subject areas, right? No one engineer is probably going to have the knowledge to design anything super complicated like the new technology we're developing today, right? So engineers have to work together. They go to school in different topic areas, and then they collaborate and get together in order to make a final product. Another thing that engineers do is prototype. So one tool for prototyping is 3D printing, right? And maybe you know how 3D printing works, maybe you don't, but it's just basically a way that you can three-dimensionally print something. And that's maybe a cheaper or, yeah, it's really just a cheaper and easier way to fabricate something in sort of a test design that's maybe not exactly like the final design, but it looks like it, and maybe you can perform tests on it. And that's what a prototype really is. It's not quite the final product, but it's something that you can test and work with to see what kind of improvements you need to make. Engineers also have to test their inventions repeatedly before they put them on the market, right? So here's an example of a surgical robot playing the game Operation. I don't know if you guys have played this game, probably some of you have, but the robot uh, trying to pull out these pieces from the operation board without sending off the buzzer by touching the sides of the holes, that is a good way to test the robot's precision and ability to grip things, right? And there will be other tests performed, like tests on animals, okay? And that is going to test the robot's ability to actually do what it's supposed to do in different ways. So in conclusion, engineers are designing new machines to help people every day, such as the Mira system, which will probably come to market soon. Very exciting. Now, normally I would ask if you guys had any questions, questions. Now, normally I'd ask you guys have any questions, but since obviously this is a video, if you have any questions, you can email us or just get in contact with us somehow, and we'd be happy to answer those questions because we love talking about that. Or you'd ask it probably. They might know. All right, so this is kind of an activity having to do with what we talked about. This is a laparoscopic surgery activity. So not necessarily directly related to the robots, but the type of surgery that robots perform is laparoscopic. But the activity we'll do will also have a little bit to do with the way that surgeons sort of see into things and control the robot without actually looking directly into the person themselves. So we already talked a little bit about the engineering design process, right? But we ask ourselves a question: what problem are we trying to solve? We imagine a solution, we get creative, we get innovative, we think outside the box. Then we plan, we narrow it down, we hash out the details, we create a prototype that we can test and improve, and then the whole process starts over again. So work in groups of 2 or 3. In laparoscopic surgery, that is kind of what we talked about before. It's when there are really small sort of cuts or holes in a person, and those allow the instrumentation to get in, and cameras are able to see inside the body so that a bigger cut doesn't need to be made, and it helps the surgery to be able to be performed with less harm to the patient and quicker recovery time. So first, you guys have to build your own laparoscopic tools. Teams of 2 or 3, choose only 4 of these materials. You can sort of pause this and study these if you want. Then you want to complete the following challenges, right? And you can sort of look at these: move pom-poms from one cup to the other cup, move rings from one nail on the board to another, write your name, unravel the Tootsie Roll. These are actually really similar to the challenges performed by actual medical students who are trying to learn laparoscopic surgery. So, and the same way they test the robots as well. So you can sort of take pride in that. If you're doing good at this, it's a very serious sort of undertaking. You know, you're learning to build the tools that you'll need and sort of practice the hand-eye coordination that you'll need and the thinking skills to perform a surgery. And these are some wrap-up questions that you can think about after you've completed the activity. Oh, there's no good place to put my face. That's all right. You get the idea. Well, all right. I hope you enjoyed it, and go ahead and try the activity, and I hope that you all have a great day and keep exploring other videos on the channel.